This lesson is about imaginary numbers and complex numbers. By the end of this lesson, you should be able to simplify square roots in terms of I, simplify expressions involving large powers of I, solve incomplete quadratic equations by taking square roots, apply the rules of complex numbers to problems involving addition, subtraction, and multiplication. In the real number system, it is not possible to take the square root of a negative quantity because whenever a real number is squared, it is not negative. The fact has a ramification for finding the x-intercepts of a parabola. So on the axis below, a sketch of y equals x squared is shown. Now consider the parabola whose equation is given in function notation as f of x equals x squared plus 1. So we know from our work in earlier lessons that this means up 1. So I am moving all the points on this graph up 1, which means it looks like this, x squared plus 1, and this graph is just x squared. So how is this graph shifted to produce the graph f of x? So we said up 1. We sketched it quickly. What can be said about the x-intercepts of y equals f of x? There are none. So they want us to algebraically show that these intercepts do not exist in the real number system by solving the incomplete quadratic. So let's do this by quadratic formula. So a equals 1, b equals, we don't have 1, c equals 1. So x equals negative b plus or minus square root b squared minus 4 times a times c all over 2a. So we have 0 plus or minus the square root of negative 4 over 2. That's a problem. I can't break down a square root of a negative. So it does not exist. This is not real. So we cannot solve the equation using real numbers. We introduce a new number called I, the basis of imaginary numbers. Its definition is given below. So if you see the italics I, that means imaginary numbers, and its definition is the square root of negative 1. So if I was looking at this one up here, I know the square root of 4 is 2. I don't know what the square root of negative 1 is, so that's what we need to contend with now. So we're going to simplify each of the following square roots in terms of I. I guess I forgot to say above that the reason there are no x-intercepts is because it's an imaginary equation, because the roots or the solutions are imaginary. So if it's not real, there are no x-intercepts. Okay, that's really important. So in number 2, we are going to simplify the radicals like we know how to do. If we want to use our calculator, we can. By now, we should be getting pretty good at knowing our perfect squares and being able to take those out. I know right away that 9 and 100 are perfect squares, but I have this negative in front. So this is the idea behind I. Negative 9 is going to change into negative 1 times 9. So the square root of negative 1 times the square root of 9. Well, the square root of 9, I know, it's 3. And I know the square root of negative 1 from the definition above is I. Well, I times 3 is 3i. You do not need to do all that work. You just need to know where it comes from. So could you just say the square root of negative 9 is 3i? Of course. So we know the square root of 100 is 10. And we know that this negative gives me I. Okay, so if you have a negative under a square root, you know your answer is going to have I in it. Then you're going to use your regular radical breakdown procedure to simplify your radicals. So 32 is 2 to the 5th. So I have 4 radical 2. But because it's negative, I have an I. So 18 is 2 times 3 times 3. So it's 3 square root of 2. And because it's negative, I have an I. So anything with a square root of a negative has to have an I in the answer for imaginary. Okay? All right. Next. Simplify each of the following powers of I using your calculator. The I button is located under pi. Well, right now we're going to not do that. We're going to use our brains. So we know I to the first power is I. I to the second power, negative 1. I to the third power, well, that's I to the first power times I to the second power. So that's negative I. And I to the fourth power is 1. So this is cyclic, which means it's the same thing over and over and over again. So I to the fifth is the same as I to the first, because I can take and rewrite this as I to the fourth times I. Well, I to the fourth is 1, so 1 times I is I. So I to the sixth is I to the fourth times I to the second. Well, I to the fourth is 1, and I to the second is negative 1, so my answer is negative 1. I to the seventh is I to the fourth times I to the third. I to the fourth is 1. 1 times negative I is negative I. Well, what is I to the eighth? Well, it's I to the fourth times I to the fourth. Well, what's 1 times 1? 1. So what you should be thinking to yourself is, if they have powers of 4 in them, then they are equal to 1 times whatever the other power is. So what we want to do when we get into these gigantic powers is use division by 4. So if I take 20 and divide it by 21 and divide by 4, it goes in 5 times. Well, I have a remainder of 1. So that means I have I to the fourth 5 times. So I to the fourth, I to the fourth. Because 4, 8, 12, 16, 20, because when I multiply it, add the exponents, times a single I. Well, I know that all of these equal 1. So 1 times I is just I. So if you just use the remainder to tell you which power to use, then you're good to go. So 38. Well, if you want to use your calculator, do 38 divided by 4. Make sure you put it back into a decimal, so we get 9.5. So that means I have a remainder of 2, because 0.5 is 2 quarters. So this is the same as I to the second, which is negative 1. 83 divided by 4 is 20.75. So that means the remainder is 3, because 0.75 is 3 quarters, and dividing by 4 is a quarter. So this is the same as I to the third, which is negative I. Now 40 divided by 4 is 10. So what is your remainder? 0. Well, that means it's the same as anything to the 0 power is 1, and I to the fourth is 1. Now, yes, you can do all of these in your calculator. Go ahead and try. But I do not want you to rely on only your calculator. I would like you to use your brain too. So we know from this pattern that all of our answers for the powers of I are either I, negative 1, negative I, or 1. So we could do a question like exercise 6, where we combine our powers. So I to the 16th, well, that goes in evenly divided by 4. So we know this is 5 times 1, plus 3 times 23 is a remainder of 3. So that's a negative I. Plus 26 is a remainder of 2. So that's a negative 1. 5 times 1 is 5. Minus 3i minus 1 means we have 4 minus 3i, which is choice 3. Go ahead, check that on your calculator. If you have any questions, ask in class.